Hello everyone. So today I'm going to be doing a video tutorial on how to use the t-table. So when I first introduced the t-table, it was to construct confidence intervals. And I explained to you guys on that PDF file how to find T sub alpha over 2, which is the boundary of the confidence interval. And I gave a couple of different examples in that PDF file. So let's go through those examples in this video tutorial. So just to go through the t-table and what information that it provides. So the t-table, the body of the table, meaning all of these numbers here, they are actual t-scores. And you have degrees of freedom, which is your row heading. So that is at this point, n minus 1. So essentially your sample size. At the bottom, you have your confidence level. So if you're constructing for instance, a 95% confidence interval, this is your relevant column. And let's say your degrees of freedom is 80, then this is your relevant row. And at the bottom, you also have your comparison z-score. So we already know that for 95%, the z-score is equal to 1.96. But of course, you're going to have different t-scores depending on your sample size, meaning depending on your degrees of freedom. So remember that the z-score never changes regardless of your sample size, right? So it will always be 1.96 if you're doing a 95% confidence interval, but your t-score will vary. It will be a different value depending on your sample size. And you'll notice that at the top, you have your smaller DF values, meaning small sample sizes. You have a large t-score. But as your DF increases, meaning larger sample size, your t-score is decreasing. It is approaching your z-score. Okay, and at the top, the first 3 rows are about area. So the area information is given only in these first 3 rows. So the first row is the cumulative probability, meaning if you're looking up a t-score, the subscript gives you the area to the left of that positive t-score. So for a 95% confidence interval, we already know from previous examples that the area to the left of the right boundary is 0.95 plus that alpha over 2, or adding up to 0.975. The second row gives you the area to the right of that positive t-score. And then the third one is both of your tails. So the third row is always going to be second row times 2. So in this case, this is alpha over 2, and this is going to be alpha. And this is the area to the left. Right? So we know that 95% confidence interval has an alpha value that is equal to 1 minus 0.95. So that's 0.05. And alpha over 2 is simply 0.05 divided by 2. And that's what gives you 0.025. Okay, so now let's work with the 3 examples that I gave you in that PDF file. The first example asks you to find the t-score for a 90% confidence interval if the degrees of freedom was 28. So because we are doing a 90% confidence interval, this is the only column that we have to worry about. I've already given you DF, which is 28. So this is the only row that we have to worry about. So in order to get the t-score for our confidence interval formula, all we do is take the intersection of that row and that column. So T sub alpha over 2 is equal to 1.701. All right, and then in example 2, I asked you to find the t-score for a 99% confidence interval. And DF in this case was 35. So 99% confidence interval. So this is the only column that we care about. And DF is equal to 35. So now, just so everything fits into a nice single page, we don't include every single DF. So it is summarized here. So we are, not including every single DF. You have a DF that's equal to 30 and a DF that's equal to 40, but you don't see 35. So it is in between these two rows. And when it comes to DF, you always round down. So meaning I'm not going to say, let me take DF is equal to 40. No, you're going to actually round down to the next lowest DF, which is equal to 30. So I will focus only on this row and only on this column. And the intersection gives me a t-score that is equal to 2.750. So this is the t sub alpha over 2 that I would use for this confidence interval. So now I also gave you the student T calculator, that website. So you can go ahead and use this website. It is an extremely useful website. So instead of rounding down, so our DF was 35, we ended up rounding down to 30. If you use this website, you don't have to do any rounding. You can actually write down the precise DF that you have. And the probability level here refers to your alpha value. So we were doing 99%. So alpha for a 99% confidence interval is a 0.01. So this is what I would put, 0.01. Degrees of freedom is 35. When you click calculate, you'll be using the two-tailed, because we have our confidence interval and a tail to either side of that confidence interval for a total of two tails. So that's why we're looking up this number. And our T sub alpha over 2 is 2.72. So if you don't want to do any rounding, this is, again, an excellent website, excellent resource to use. Okay, so now the third example that I gave you was find the t-score for a 99.9% confidence interval. So this is our column of interest, and DF is equal to 999. So again, you don't see 999. You see DF is equal to 100 and DF is equal to 1,000. So even though we're much closer to 1,000, you're still going to be rounding down if you use this table. So instead of this row, we'll be using this row, round down from 999 to 100. And this is your relevant column. Get the intersection. You get that your t-score is going to be 3.39. So this would be the t-score you put into your confidence interval formula. All right, so again, you can, if you don't want to round down, you can definitely use the student t-value calculator. So in this case, our degrees of freedom is a 999. If we're doing a 99.9% confidence interval, alpha is going to be 1 minus 0.999, or alpha equals 0.001. When I click calculate, this is the t-score that I get. So the very precise t-score for DF equals 999. is 3.30. So this is what you would be putting into your confidence interval formula. All right, so, and again, you'll notice that we got 3.39 for our t-score, which is larger than the z-score we would be using if we were doing a 99.9% confidence interval with a z-distribution, right? And then in the second example, we got 99% and DF is equal to 35. So we ended up with a t-score that's equal to 2.750. And again, that's still greater than the comparison z-score for that same confidence level, right? So this just shows you that the t-distribution is a distribution that is designed to punish us for having to use an estimate of the standard error rather than the true standard error. So that's why the t-scores are larger than the z-scores. And as your DF or your sample size increases, you are punished less. That's why the t-scores a decrease in value approaching the z-score. All right, and of course, since you are given the z-score for a variety of confidence levels, you can also use that very bottom row here to work to find your z-score if you're doing a confidence interval with a z-distribution. And remember that we always use a z-distribution with proportion mean, meaning pi hat and pi, and we will be using a t-distribution for everything else.